Okay, so if we create, so if you did this problem on your own, we're going to create a quick little chart. So I'm going to say time, and then my x was equal to t, my y is equal to negative 2t, and then here's our coordinates that we're going to plot. So negative 2, negative 1, 0, 1, and 2. So if I plug in negative 2, that's easy. Negative 2. Negative 2 times negative 2 gives me positive 4. So this would be negative 1. And then 0, 0, 0. That's lovely. So 1, negative 2. And then last but not least, 2, negative 4. So let's go ahead and plot these points. So negative 2, 4. Right there, and negative 1, 2, 0, 0, boom, and boom, right? So negative 2 to 2. Again, we're going to draw our line to the best of our ability, and direction tells me I'm going here. So something else we can say, I didn't say it on the last problem, but we can say, as t, aka time, increases, the graph moves, graph moves, I was going to say moves twice, graph moves to the right. Okay, so again, we indicate that with arrows. So we can not only say it in words, but we can also say what's happening. Okay, last but not least, so we sketched, bam, orientation, bam, rectangular equation. So let's get rid of our parameters. Well, the great thing is that this equation is super simple. X is equal to t is already solved for you, so I'm just going to replace the t with an x, right? So over here, so my new equation is just y is equal to negative 2x. There's my rectangular equation, and this makes sense. I don't have a y-intercept, it's at 0. My slope is negative 2, so down 2, and then over 1. Again, down 2, over 1, down 2, over 1. We would just have to figure out where we want to start our time, so to speak. All right, let's try a few more. So again, same directions. So number 3, let's sketch to the best of our ability, orientation, and then rectangular equation. So x is equal to the radical of t, y is equal to 3t plus 4, and t is going to be greater than 0. Okay. So on this one, let's not plot points necessarily. Let's get rid of our parameter first. Let's switch it up a bit. Okay. So I still think that this equation is still the easiest to solve for. So I'm going to solve for that equation. And all I'm going to do is I'm going to square both sides. So square and square. So I'm going to get x squared is equal to t. So now that's equal to t. I'm going to go ahead and plug in x squared everywhere I see a t. So that'd be right there. So I'm going to get y is equal to 3x squared plus 4. Okay. So now I have an idea of that it's a parabola. Okay. And I can, so I know that it's opening upwards. I know that I have a y-intercept at 4. So now I can kind of figure out what's happening. So if I look back at my first equation, okay, where my t was greater than or equal to 0. So the reason why we did this information right here is because I can't plug in a negative value in for x, which means x is actually going to be, so not only is that, x has to be greater than or equal to the number 0. So I actually can just start with x is equal to 0. So if I plug a 0 in right here, 0 squared is 0, 0 times 3 is 0, 0 plus 4 gives me 4. So I actually start at the point 0, 4. So what happens when I plug in a 1? Right, if I plugged in a 1 here, radical of 1 is still 1. So just 1. So 1 squared is 1. 1 times 3 is 3. 3 plus 4 gives me 7. So at this point, it's off my grid because it only goes to that. So I know that I'm heading this direction. Again, I don't want the full parabola. I only want this information. And again, draw my arrow to continue. And that's it. We're done. Okay. So again, we sketched. We have an orientation because we have an arrow. We have a rectangular equation because we've gotten rid of our t parameters. All right. Let's try another one. So again, same directions. So this time x is equal to t squared plus 2. Y is equal to t squared minus 4. And I'm going to say that this time t is going to be any number. So we can plug in any number in for time. Okay. So this one can be a little bit trickier, right? So again, I'm going to get rid of my parameters first. So I'm going to subtract 2 to both sides. So I'm going to get x minus 2 is equal to t squared. I'm going to go ahead and replace that guy in for that. So this will be y is equal to x minus 2 minus 4. So y is equal to x minus 6. Interesting. Notice that I had a squared in it, but notice that this actually ends up being a line. Okay, so let's say we drew this line, right? So I would start at -6, and my slope is 1, so I'd be going up 1. Right? Again, I ran out of room, so let's pretend that it would look something like that. I'm not going to connect my points yet because I actually don't know what's going to happen. So I want you to think about these original parameters. Okay, anytime you plug in a squared, right? Or anytime you plug in any value for t, we're going to square it. So I want to know this question, right? What is the smallest x value we would get? Okay, what's the smallest x value we get? So if I plug in a 1, 1 plus 2, right, would give me 3. If I plug in a -1, it's still going to give me 3. Right? If I plug in a 2 or a -2, right, 4 plus 2, it will give me 6. So the only number I can plug in that's going to be really, really small is when t is equal to 0. So that means if I plug a 0 in for that, all my numbers for x are going to be larger than 2. So now if my x is larger than 2, looking at my graph that I've kind of drawn, right, I don't want to include this number because my x is smaller than 2. I don't want to include that number, that number, or that number. So I want to start at +2. So when t is equal to 0, notice when I plug a 0 in, 0 minus 4 gives me -4, and boom, there's my output as well. Okay, so again, it doesn't matter which one you start for. You can kind of look at it in both ways. So if this is my first one, again, slope, it's going to go this direction. So boom. And then there's my line for my parameters. All right. Let's get a little trickier. Let's cut back. Maybe potentially might need, let's plot some points when we do this one. So x is equal to t squared minus 4. Y is equal to t over 2. And let's do our time. Let's go back to between -2 and 3. All right. So this one could be a potential a little bit more challenging because I see a fraction and a squared in it. So I'm going to set up a chart because you can't go wrong. Again, if you want to pause the video and try these on your own, I highly recommend it. So -2, -1, 0, 1, 2, and 3. And -2 to 3 is usually a really good indicator for our numbers. And then y is equal to t over 2, and then x comma y. Okay, so if I plug in -2 squared minus 4, that's going to give me 0. -2 divided by 2 gives me -1. So 0, -1. It's a good number. And that's going to give me, what, -3. And -1 over 2 is the same thing, -1/2. So let's leave it like that. 0 squared minus 4, so -4. And that's going to be 0 over 2, which is just 0. and 1 squared minus 4. Again, we're going to come back to this. It's going to be negative 3. So 1 over 2, that's a positive 1/2 this time. 2 squared, that'll be 0, so again, it repeats here. 2 over 2 gives me a positive 1. And then 3 squared minus 4, so 9 minus 4 should be 5. And 1.5, well, leave it like that. Okay, so let's go ahead and plot what we know. So 0, negative 1, I'm right there, negative 3, and let's just say it's probably right about there. Negative 4, 0, boom, positive 1/2, 0, 1, and then 5 and 1.5. Okay, so it kind of looks like it's happening. It's going in this direction. So it almost looks like a sideways parabola. All right, so I'm going to draw my arrows. This is how we drew it. All right, so let's see what happens. When we're solving for our t, I think it might be easier to multiply both sides by 2. So 2y is equal to t. So I'm going to say x is equal to 2y squared minus 4. So x is equal to 4y squared minus 4. So this definitely is a sideways parabola. So we can see that. We can leave it like this if we want to solve for x. This would be x plus 4 is equal to 4y squared divided by 4. So x plus 4 all over 4 is equal to y squared. Technically, this would be plus or minus the square root of x plus 4 all over 2 if we want to get nitpicky. But again, this problem is perfectly fine. Okay. Perfect. So in our part 3, we're going to do 2 more problems, and these parameters have trig in them instead of our normal x's and y's, but we'll talk about how we can actually get rid of our trig in part 3.